Hello. Welcome to the Alex webinar, Putting the Link and Linked Data, which is part 1 of the 5-part series from MARC to BIBFRAME, Linked Data on the Ground. I'm Allison Armstrong, Collection Management Librarian at Radford University, and I will be your host for today's webinar. Our presenter today is Nancy Lorimer, the head of the Metadata Department at Stanford University. She oversees metadata creation and participates in linked data projects and planning. She is a core participant in both the linked data for production and the linked data for libraries, Labs Mellon-funded grant projects. Nancy is also a consultant to the PCC task group on URIs in MARC. There are a few things to keep in mind for today's presentation. All attendees are muted. If you have questions for Nancy, please type them into the question box on your screen and Nancy will answer them at the end of the presentation. We do not have interactive chat capabilities. If you wish to use Twitter to comment on today's presentation, you may use the hashtag you see on the screen. We do not monitor the Twitter feed, so please use the question box to submit questions and comments. This webinar is being recorded and you will receive an email with links to the recording and presentation slides within 2 days. And now here's Nancy. There will be a slight delay as we change presenters.
Okay, hello everyone, and welcome to today's webinar. Here you have, Okay, here you have a photo of me in my usual untidy state, along with some contact and bio information if you wish to follow up with me about anything I talk about today. I will mention about my background that, like many of you here, my background is as a cataloger, a music cataloger to be precise, not a semantic web architect or even a metadata analyst. What I will be talking about today is something we catalogers will likely be working with in the not too distant future, and some of us are actually using right now. It seems so different to us, yet at its heart, it has the same goals as we've always had, to provide metadata for library materials that enhances both access and discovery. This webinar series aims to follow a pathway that will lead us from our current MARC-based cataloging to cataloging in native linked data. The first three webinars following the LC BIBFRAME update that many of you viewed last week are about transforming MARC records into linked data, specifically BIBFRAME. The fourth webinar will explore the modeling and encoding of serial, that always challenging format. And the fifth and final webinar will bring everything together in a discussion of linked data cataloging workflow. In this webinar, we will start with the basics. Basic advantages of linked data, most importantly, the importance of the URI in linked data, authority creation versus entity management and what that means, URIs in BIBFRAME, and the potential workflow for URIs in MARC records. But before we move into that world of URIs, let's stop and think about where we are now. I'm sure all of you have listened to various talks and discussions about linked data. Its promise, its lack of promise, that MARC is dying, that MARC is perfect. Well, maybe not quite that MARC is perfect. But let's take a final look at a MARC record, how the data in it is presented, and the context of its data in relationship to the web. One thing you probably regularly hear about linked data is that it will make our library data more accessible on the web. But this can be a confusing statement. If I perform a Google search for Anthony Doerr's All the Light We Cannot See, this is what we get as part of the result. 4 of these are hits on bibliographic arrows, as shown with the arrows there. Bibliographic records. 1 is at Stanford and 3 are in WorldCat. So it looks like it's already accessible on the web, and indeed it is in a way. If I click on the Stanford link, I get the bib record for the book in the law library at Stanford, as displayed in the discovery layer of our catalog. We went from one web page to another web page. This was done by matching a text string that was equivalent to, or at least reasonably close according to Google's algorithms, the search I entered. This linking, while of course very useful, is not really linked data. We are linking documents through text strings, whereas linked data links data elements through identifiers in the form of URIs, or Uniform Resource Identifiers. In the first, a computer might not know that it is searching a title without some extra programming. In the second, it is semantically coded into the data. Because of how the web works, this is difficult to see, but it is a very important difference. So here is the MARC record for the book hidden behind our discovery layer as it appears in OCLC. Except for the rather momentous number of subject headings and genre terms, this is a fairly standard bib record for a novel. Every field contains one or more pieces of data about the book, its title, author, edition, publisher, pagination, etc., and that it won multiple awards. Much of this data is presented in the form of controlled vocabularies, which are identified either by an indicator or a subfield 2 with a code for the vocabulary, as you can see in green here. The record also includes a number of identifiers, some for the whole book, as in the 020 and 024 up in the left-hand corner, which are ISBNs and EANs, and others are control numbers for authority records from various vocabularies, here terms from FAST and the German National Library over on the right. There are other parts of the record as well that could be taken from controlled vocabularies, such as these, though they don't show it, and a few others that actually could be controlled vocabularies, though currently the information is given in a note, in this case such as the place of publication and the publisher, and various awards for the book. But how do we know all this data is actually related to the publication, all the light we cannot see? And how do we relate this data to it? Well, there are two ways. First of all, the data is in a single database record, and that record has numerous fields that we display with person-friendly text. But secondly, and most importantly, we read the data. We read bibliographic records and fill in semantic relationships between these various chunks of data. This is easy enough when there is a single work, as with this book, but much more complex when you are dealing with a compilation, such as a sound recording, where each individual work may have specific data that relates only to it. And again, it requires a human to read it and put this all together. So despite all those identifiers that are there, the relationships are somewhat opaque to a computer. The metadata is what you might call inarticulate. Even when we click on the few provided links in the record, we move from one record in a database to a record in another database. As with the BIB record, authority records depend on the database structure and human reading to provide semantic structure. Otherwise, you simply have a set of text strings. As with the bibliographic record, if this data were atomized and sent out to the web, it would lose all the relationships and other semantic meanings. And yes, I will turn the volume up. So what does linked data offer that MARC does not? As we noted on the previous page, data elements in MARC are linked together by the context of the database record. Identifiers for various elements, when they exist, are either text strings, and relationships between data elements are expressed either as free text notes or controlled text strings. Context and human interpretation are always necessary. As linked data, however, data elements are linked together as independent statements about how they relate to one another and are not tied to any record format. Identifiers are URIs, which are machine actionable through standard web protocols and can carry semantic meaning. Finally, relationships are expressed as RDF, or Resource Description Framework, triples, in the form of URIs and are machine actionable. We'll talk more about that later. Now, this is easy to say, but it is not always so easy to understand how this works. So let's now turn to the primary emphasis of this talk, the URI, its place in linked data, and how it works. So to the URIs, which I call the workhorse of linked data. Tim Berners-Lee, the brains behind the World Wide Web and the impetus behind the idea of the semantic web, formulated 4 famous rules that govern the basic structure of linked data. They are: use URIs as names for things. The second, use HTTP URIs so that people can look up those names. 3, when someone looks up a URI, provide useful information using standards. 4, include links to other URIs so that they can discover more things. Many of you are quite familiar with these rules, but it's worth going through them again one by one to understand exactly what he's saying and how the URI is key to linked data. Okay, first the first rule, use URIs for things. This rule is often described with a slightly more poetic thing, strings versus things. Instead of using a text string to identify something, you use a URI, again, a uniform resource identifier. You can identify anything you want with a URI, a person, a place, a thing, a concept, a make-believe thing, an emotion, whatever you want. Doing this allows you to link other data to your URI that may further describe it. You cannot do that with a text string. You can create a URI yourself by simply declaring a namespace and assigning unique identifiers within that namespace. Usually, though, we try to use URIs that have already been minted by some organization or person we trust. My examples on the screen show some things that are commonly used in bibliographic data: names, titles, genres. On the left, they appear as text strings, basically how they tend to appear in our catalogs. On the right is URIs from various vocabularies specifically for library data. The Virtual International Authority file, first, the VIAF up there, the LC Name Authority file, WorldCat Identities, and the LC Genre Form Thesaurus. These are all sources that we trust fairly well in the bibliographic world and are very familiar with, and they are all published as linked data. The second rule of linked data refines the first. Use HTTP URIs so they can look things up. URIs can be used in a variety of ways to identify a variety of things, and they come in a few different formats. At the top of your screen is what was once and still often called a URN, or Uniform Resource Name. This is an identifier that is machine actionable in the right circumstances. It is made up, as you can see, of the prefix URN, followed by a namespace for that particular URN type. You might see examples, some familiar terms in the examples. We have an ISBN, an ISSN, and ISN, which is for ISNI, the International Standard Name Identifier, followed by an identifier for the individual object or agent. So as the name suggests, this type of URI identifies a resource by a name in a particular namespace. You will notice, however, that this is not an HTTP URI. So the URN actually violates the second rule of linked data. It is actually true that this type of URI is often easily transformed into an HTTP URI through computer processing, but the extra step is not ideal in linked data. Our second type of URI there in the middle is one that represents a web document, such as we saw with the Stanford bibliographic record. Once officially, and now informally, it is called a URL, or Uniform Resource Locator, to differentiate it from other URIs. Basically, it is an address for a web document. In other words, it takes you to a document about the resource rather than to the resource itself. The URL does follow our rule for HTTP URIs, but it does not actually point to data points. It points to a document. Because of this, it is not actually the URI that drives linked data, but instead something that linked data may eventually arrive at and no longer link to. And so we come to our last type of URI. This URI is a URI that is used to identify a thing, or more formally, an entity, usually something that lives outside the web in the real world. It could be your dog, it could be you, it could be your favorite genre of fiction. Here I actually just have, I think it's my own ORCID ID at the bottom, an ISNI ID for someone, and a name record from VIAF. It is specifically points, however, to a data element rather than a URL that takes you to a document. This is the HTTP URI of linked data, a URI that links data points over the web. But why use an HTTP URI? HTTP URI makes use of the web protocols governed by HTTP, which makes it an integral part of the web and of web protocols. As the rule says, you can look things up with it. But with a URI for the thing, you don't actually see anything without it being linked to something else. And this is where we get to our next rule. And that rule is, when someone looks up a URI, provide useful information using the standards. In other words, your URI should link to something a person can read and can give you more information about the entity, such as a web page. If you look at this URI, it will immediately flip you over to another link that is something for you to read. This is what is meant by dereferencing. So in this case, the URI has dereferenced to the MusicBrainz page for Leonard Cohen. And you can see that it does have all sorts of useful information, a biography, a discography. You can also see over at the right that there are further links. And this brings us to our final rule. Include links to other URIs so that they can discover more things. Here's a list of links as given for Leonard Cohen in his PIAF record. Each links out to yet another set of information about him. Now, these don't look like URIs to you because the URI is actually hidden behind a more readable human-oriented label. But they are there behind it and will link out to various data hubs. So all of this might seem a bit theoretical, and it is, and it seems a little nitpicky. But let's stop a moment, go for a breather, and to think about the implications of this. Look at the screen in front of you, and I'm going to ask you one question about this screen, and I want you to answer quickly to yourselves without much thinking. This is not a formal poll. So the question is, what is this? So, what did you think? I'm pretty sure many of you automatically thought it's a cat. Others of you, especially those who didn't follow my instructions and thought about it before answering, may have thought this is a photo of a cat. The first answer is, of course, a perfectly normal way of human thinking that we do every day. Of course, we all know that this is not an actual cat, but the human mind is easily able to make a shortcut between a thing and the representation of a thing and not be confused by it. A computer, however, is not able to make this leap on its own. If you were to tell the computer that this is a cat, it will, for a lack of a better word, believe you. But any statement you make about that living cat will now be linked instead to a photo. This could result in some very curious assertions. You might end up saying the photograph has yellow eyes and soft dark brown fur. So now to our second answer. This is a photo of a cat. This is, of course, more precise, and what it does is it clearly differentiates the cat as an entity and the photograph of the cat. The entity URI may dereference to the photo URI, but any statements about the entity will be linked to the URI for the entity, not that for the photo. We can, of course, get even more precise in this third statement. This is a PowerPoint slide containing a photo of a cat. This kind of shows more the ambiguity of my question in the first place. The question asked, what is this? But what do I mean by this? Giving this a unique URI removes all that ambiguity. So the main thing, though, to remember is this is not a cat. So where do we find URIs to use in linked data applications or to aid us in moving our MARC data to linked data? There are many pools or hubs of resources for URIs available in many subject domains on the open web, and many of them are library-based. Here are some of the well-known library and researcher-based sources for names, either of people, corporations, or families. Most of these will be familiar to you even if you never use them. At the top, I have the International Standard Name Identifier, or ISNI, which is for names and corporations. It's an international list. The Union List of Artist Names, also known as ULAN, which is out of the Getty Museum. The Virtual International Authority File, which we've mentioned already, which interestingly enough brings together identifiers from a number of library authority files, including LC, ULAN, and various national libraries, Wikidata, ISNI, ORCID, and others. And then there's also the Faceted Application of Subject Terminology, or FAST, that comes from OCLC. Many of you think of this only as a subject database, but of course people can be subjects, so there are names in there as well. But of course, entities can be for anything, not just can be anything, not just people. So here are some sources for URIs for other types of entities, still primarily associated with libraries. Again, we have FAST, and then the medical subject headings. I could have also mentioned the Library of Congress subject headings, so they're a little more complicated. The art and architecture thesaurus, geonames, which does obviously geographical names of one sort or another, and Wikidata, which is a linked data version of Wikipedia. Now that we have some ideas of how these URIs work and where they might come from, and we'll now consider how that relates to our own authority work and the authority work records we create. Using URIs rather than text strings to uniquely identify entities opens up new possibilities along with new challenges in our management of library authorities, particularly for names. The emphasis here moves away from the creation of canonical authority records to assigning attributes to a URI, reconciling that URI with other URIs, and otherwise handling how it links out. This can be described as the work of entity management as opposed to authority creation. Let's take a look at how this might work out. Here again are two traditional authority records, familiar to all of you, one for Anthony Doerr and one for Leonard Cohen, the singer. The records, of course, are created according to RDA standards as required. Even so, we can see that the amount of information provided in these two records varies quite a bit. The record for Doerr contains what are basically the minimum requirements. The record for Leonard Cohen has much more information. As with bibliographic records, almost all the information in authority records is recorded in text strings, the semantic meaning of which is created by the database structure. Since the text string is the primary method of disambiguating the name, only one form of the name is authorized. Others are relegated to being cross-references. Being qualified to create these records requires a fair amount of investment in training and time, both in RDA and specifically as part of NACO. Only a cataloger can create or add data to this record. Not all libraries have the personnel necessary to belong to NACO, and NACO catalogers may encounter names that they cannot differentiate or otherwise cannot confidently add to the database. For instance, if they are in an unfamiliar language or script. This means that despite our best intentions, not every name in our catalog is going to be accompanied by an authority record. My own institution is a case in point. Stanford is a long-term member of BIBCO, and most of our original cataloging is done according to the BIBCO standard, which includes creating records for all access points. Excuse me. We do also have exceptions, though. Sometimes there is simply not enough information to create a unique access point, or there is some other impediment. Also, though we create authority records for all our original cataloging only accounts for about 20% of our bibliographic records. The rest comes from vendors and from other libraries who may or may not have created authorities for those records. And like many other libraries, we have records that predate authority control policies. All in all, despite our good intentions, at last count, we have near to 1 million headings in our catalog that are not linked to authority records. And that doesn't even bring into account the stuff we have in our digital repository. So this is our slightly depressing reality. Using URIs, however, moves the emphasis on record creation to the basic task of disambiguation. And this can be carried out in a very basic manner. Just assign every entity a unique URI. The URI may be taken from a nationally or internationally recognized set of identifiers, such as BIAF or ISNI or ORCID, or if that is not possible, minted locally in a local namespace. The URI must be unique, but any label for that URI, in other words, what you actually read, does not need to be unique. A URI could potentially have several labels, perhaps depending on language preference or competing input standards. And some of those labels might be exactly the same as labels for a different URI. It does not matter. And unlike an authority record, URIs are not tied to isolated records, and they are integral to your description of a resource, so that one URI can be used for multiple descriptions of multiple bibliographic resources. So in this case, I have created a URI for Leonard Cohen in a hypothetical Stanford namespace. That is not our real namespace. Usually, of course, a local URI, if I was creating something like this, it could be created automatically, computer process, if no other identifier was provided. So the benefit here is that every single entity in your catalog would have a unique identifier. This is very much unlike our current situation. Now, immediately you can see, though, there are some difficulties of this. I gave Leonard Cohen a URI, but clearly no one else will give him that URI. Another person might assign him a URI in another namespace, and someone else in yet another. In an ideal universe, of course, everybody would somehow manage to assign exactly the same URI to everyone else. But as this is not really reality, the web is very large, and there is no way it would ever happen. So how does a computer even know that they are the same? So I may have created this Stanford URI when no URI existed, but then find out that a URI has since been created by an ISNI, say. We now need to link these two identifiers through a process called reconciliation, stating that two identifiers represent the same entity. This is usually done with a same as statement in either one of two web ontology languages, Schema or OWL. We'll go into that structure of that a bit further on. Reconciliation can be difficult, especially if I have a lone URI like the one I provided above. The best way to get around this, of course, around the issue of reconciliation, is to use the ISNI identifier in the first place. Then your entity is already reconciled with all the other places in the web that use that URI for Leonard Cohen. But unfortunately, this is not always possible. But not only that, in some cases, some URI services provide reconciliation to numerous recognized identifiers, such as the case with the virtual international identifier file. On the left, you can see the human-readable version of the sort of record for Leonard Cohen, which is basically a mashup of information from authority records from major libraries around the world that are linked together through one entity URI. You notice, remember, in VIAF, no one form of a name is preferred. Each library has its own preferred label, but they are all linked together by this one URI. The actual coding on the right shows that these terms have all been declared same as each other. You can see that same as there. Because of this, you can assign one recognized URI from this set and be automatically reconciled with all the others that are there. So that makes VIAF a very useful service. Reconciliation of URIs by machine or by a person cannot take place without some context, however. Two isolated URIs have no individual meaning in themselves. It's statements about those URIs and the relationships that do. While you literally only need to create a URI and no more, generally speaking, a URI would never be created as an isolated thing. A URI with a person will generally be related to a publication or a description of him as a poet. This context is taken into account by various reconciliation engines. For example, here we have one on the left and on the right two URIs. The hypothetical one I created earlier and one from Wikidata for Leonard Cohen on the right. Each URI, however, shares a number of equivalent statements: that the entity has the name Leonard Cohen, that he was born in 1934, he was born in Montreal, and that he is a poet. With this amount of information, reconciliation can take place fairly easily, even by machine. Without these relationships, though, reconciliation becomes guesswork or requires manual intervention. Even if machine reconciliation is possible, intervention by a human, namely a trained cataloger like many of you, will always be necessary. A case in point. Take a look at this listing above from VIA, these 4 headings. Each of these 4 headings actually refer to one individual person who happens to be my father. You will notice that there is even an exactly matching text string in each heading. John W. Lorimer, John W. Only the alternate name Jack Lorimer is somewhat different. Presumably, the algorithm that reconciles names looks at information other than the text string in the records each name came from, and that information was found wanting or conflicting in some way, and so the names were left unreconciled out of caution by the machine algorithm. If you actually went into each other record, you will find this is basically true. The authority record from the LC authority file is fairly full. It's the one with the little American flag there, even containing a sample title, which you can see on the right. The Canadian record, on the other hand, only gives his name, as does the Japanese record. But why the French record, the first on the list, and the American record did not reconcile, given the book titles in the same domain, alcohols with hydrocarbons and alkali metal and ammonium chlorides, is not really that clear, but perhaps it was not felt to be close enough to count, or the algorithm didn't actually look at these. There is also the issue that my father has all these authority records from these countries because he has publications associated with all these countries, one of which is noted in each individual authority record, but not in many in one. This is not the least bit uncommon for a scientist to be publishing in multiple countries, but it does bring in a whiff of doubt to any reconciliation process. Now, there is one outlier in this list, and that's that sample title at the top right, the Presbyterian Experience in Egypt, 1950 to 2000. I can guarantee to you that this was not written by who was a chemical physicist and probably knew very little about Presbyterians in Egypt. The linkage comes through the name Jack Lorimer, which he used on a single publication after his retirement. It somehow has been linked to another Jack Lorimer, presumably, through a record from the Netherlands. I cannot tell why this has happened, but it does show that computer algorithms are not perfect. But the odd error notwithstanding, this does suggest that more information provided about an entity, the easier the reconciliation can be. But it needs to be the right information, and it is not fail-safe. Again, there will always be a place for human decision-making and remediations of linked data. Unfortunately, VIAF at this point does not have a public means of doing this within its own system. Okay, so let's take a slight break again from the theory of this and go on a short visual journey that shows the power of reconciled URIs in moving you through the semantic web. Start again with the record for Leonard Cohen. As we already see, it lists various forms of his name derived from various library standards over the world and brings them together under one entity URI. Just for color, we are also given a picture of a book cover and the ISNI ID in its non-URI form there in the top part. When we scroll down the page, we can see that these titles link out to other resources and that there are even yet more links to co-authors, to regions of the world, to publishers, and even to publication statistics. Here are some selected co-author and regional sections opened up. The regions of publication are nicely graphically illustrated using a world map and can give you an instant idea where his popularity in publication was in different type parts of the world. Back at the list of names, we'll go to the second from the bottom, which is the URI for Wikidata. And you can see it here both in human readable and in machine readable form. If we click on that link, we come to a reference to the Wikidata page for Leonard Cohen. Here you have even more information about Leonard Cohen with citations and multilingual entries and how his name is spelled in multiple languages there on the right. Obviously repetitious with the Roman alphabet languages, but this can be really important with varieties of transliteration into other scripts. Moving down the page, we can see there are specific links to other URIs. So the URI format is covered up again by human-friendly labels. These are a bit mixed. There are a few URLs in there, but the point is they all lead again somewhere else. If we click on the top link, we dereference to the MusicBrainz page for Leonard Cohen. MusicBrainz is a large linked data source for music. And so we are also presented with a very detailed listing of his albums and information about those albums. Also note over on the right that information from other sites are brought on top, that information from Wikipedia is brought into this record. On the right, we actually have some more external links, including BBC Music. So if we click on that, we end up here at BBC Music, which has basically recordings of how it's performed in the BBC and various things about Leonard Cohen himself. The BBC Music site looks just like a normal web page, but it is in fact an aggregation of information brought in through linked data and combined with local information. So we will end our tour here, but this page actually links through to others as well. Get it. So we have talked about URIs and seen them at work, but in all this, where does BIBFRAME fit in? So far we have looked at URIs primarily in their role as identifiers of entities, people, genres, etc. In a single case, we have seen a URI that lacks as a link between those identifiers, the schema same as. But clearly we need to define more relationships than that to make our data semantically articulate. This is where an ontology such as BIBFRAME comes in. It provides semantic meaning to the RDF triple by providing vocabularies that reflect the makeup of a certain knowledge domain. Let's see how that works. BIBFRAME, again, is based on RDF, the Resource Description Framework, which is the basis of all linked data. RDF structures data into what we call triples, consisting of a subject, a predicate, and an object. On the screen here, you can see two triples presented. First, we have the subject, this book, which actually acts as the subject of both the triples. In the middle, we have what we call the predicate, which defines a relationship between two entities. Finally, we have the object, the entity that is being related to the subject. If this sounds a bit like a grammar class in elementary school, well, that's because basically it is. In linked data, of course, words are replaced by URIs. We can have a URI for the book, for historical fiction, and for all the light we cannot see. I have it listed up there. But all this is really saying is this thing is somehow linked to historical fiction and somehow linked to all the light you cannot see. Again, clearly we need a little more than that. So here again are our two basic desired triples. First, that this thing has a genre that is some genre. This thing has a title that is some title. And this thing, in addition, is a book that I've added on the left. Through the BIBFRAME ontology, we are provided with URIs that define that semantic meaning of those particular triples. First, we have a URI over on the left that says this is a text. That'll be the second URI below. The first one is actually for the thing itself. Next, we have the predicates, one that says the text is a genre, has a genre there, and the other that says it has a title. Finally, over on the right, we state that the object in one case is a genre form, and the genre form is historical fiction, is the URI below that, and also that it has a title, and the title is All the Light You Cannot See. Now, writing out all these URIs, of course, is a bit of a pain, and they are also rather difficult to read and easy to mix up. So most of the time, you will see a shortcut that looks like this. Instead of writing out the whole thing, you first declare that what follows is in a particular namespace or spaces, and that you are representing each namespace in your particular code, in a particular code that is provided by the makers of the ontology. In this case, our code is BF for BIBFRAME. So when you see BF:text, that actually means http://id.loc.gov/ontologies/BIBFRAME/text. As you see, this is much easier to work with, especially on a PowerPoint slide. Of course, this is not how your coding also appears in reality. RDF is serialized in a variety of formats, RDF XML, NTriples, Turtle, JSON, etc. Turtle is perhaps the easiest for people to read, so let's take a quick look at what it looks like here. So this is what my two statements really look like with RDF serialized in Turtle. The first three lines declare the namespaces being used and what prefix will be used for those namespaces. We have RDF, we have to declare that, and RDFS, which is a slight extension of RDF, and BF for BIBFRAME. After that, the first line states that the entity 85226410 is a BF work and is also a BF text. The A meaning an RDF type, a basic relationship defined by RDF that makes something part of a class of an object. Then it lists two statements about the entity below that. First, it has a BF genre form, whatever that URI is, and a BF title, whatever that URI is. The two separate things below define that URI. So that URI, that the BF genre form, it says it is a genre form and it has the label historical fiction, and the other that it is a title, and in fact a work title, and it has the label all the light we cannot see. So in this case, you can now see that the semantic framework is built into your RDF. Okay, so we move now to our final topic for the day, which is really, in a way, an introduction to the second webinar in this series, the embedded URI in MARC, that's being given by Jackie Shea next week. I will, however, give a little general introduction and a couple of alternatives that will set the stage for her. It is all very well to provide URIs for native linked data, but what about when we are converting MARC to BIBFRAME, or indeed to any type of linked data? URIs don't just magically appear when you convert. There has to be some way to connect them to the data you are converting. Here I will talk about a few possible workflows that may be used on their own or together in a way that gets your URIs into MARC and thus convert them to BIBFRAME. So we have four basic points in which you might add URIs to a MARC record to ready it for conversion. Either you could receive copy from a source that already supplies the URIs. This is, of course, if you're doing copy cataloging in one sort or another. Or you can get it from what I call a souped-up version of your own local authority file. You can add identifiers while cataloging through various lookups or by minting the local URIs. Or finally, you can bring them in after you convert through an outside service, possibly your authority vendor. For vendor-supplied cataloging, such as something you might get from Harasowitz or Casalini or someone like that, ideally we are looking at our first option, receiving URIs with the copy that they send you. This lessens the stress both on your own local system conversion requirements and undoing lookups to outside databases, since one supplier would provide URIs for multiple customers rather than requiring them to look them up individually. In the case of vendor-supplied cataloging, it strongly suggests that it would be in our interest for the vendor to provide URI in the copy they send, and in their interest to do so. Some vendors, notably Casalini Libri, are ramping up to provide this service to customers, and others I know are looking into it. This is very much part of a workflow we are working on as part of linked data for production. Similarly, for general copy cataloging, it would be preferable to have copy that is already populated with URIs. If, for example, OCLC provided a profile that allows you to download the URI with their copy, again, you would have a pre-populated MARC record for conversion with little stress on anybody's systems or servers. OCLC actually is currently looking into this, though of course it might take some time to implement. But what if your vendor or OCLC does not supply URIs with their copy, as many will not for a long time to come? Another possibility comes from your own local authority file. It is possible to add URIs to your local authority records to store them for use in conversion. This is something Stanford has actually experimented in with the first version of BIBFRAME. As part of our regular processing of our data, our authority vendor Backstage send us authority records enhanced with URIs for id.loc.gov, VF, and ISNI. These are added to our local instance of the LC authority file in local fields. So if the authority record is changed anyways, identifiers are not deleted. When we transform the MARC record using the LC converter, a lookup is performed using the internal identifier that links the BIB field to the authority record. Any identifiers then can populate the MARC XML record and move on through into the BIBFRAME description. This method does have some weaknesses. Most obviously, of course, is that the authority records need to be present. Many vocabularies are not available through your authority file, such as RDA vocabulary, so it will be limited usually to names, subjects, and various genre or other things you have put in there. The addition is also only local. There is not benefit to any others that are using the same MARC record. On the other hand, your authority vendor is adding URIs to your authority records, and it could do so to anyone who subscribes. Also, it does relieve some pressure on servers of those maintaining the URIs you are searching for. To link, one does need to do a lookup in the files you're linking to. And with a BIB record, this can be a lot of lookups and can slow servers down. If you have no URIs provided and your local authority file comes up empty, then you move on to more local resources. You have a few choices here. First of all, if you are lucky, the converter you will use will be able to do lookups for you. This is possible, but it takes a thoroughly thought out converter that goes to the URI sources that you want to harvest. Second, it might take some scheduling depending on how you do it. If one library is doing lookups in the name authority file for many BIB records, that might be okay. But if every library is doing it at once, it might get a little more difficult. This is the same issue with other resources, not only at LC, from ISNI to RDA, etc. They have not really been tested by large-scale lookup numbers. Instead of doing lookups, you could actually just add your own local identifiers. This means, of course, that you might want to reconcile them to more internationally recognized identifiers in the future, if possible. It may be, however, though, that this might be your only identifier forever if no international file contains it. You then do have to store those URIs and keep them accessible and up to date. Finally, if you do create local URIs, you can then take another step and send them to the authority vendor to be reconciled with other international identifiers. I know that Backstage Library Works has experimented with this to some extent, and it's possible others have done so as well. As an alternative, you could skip the local lookup or addition of local identifiers entirely and send what converted data you have to your authority vendor if they were to provide that service. They could then provide URIs if they possibly could, and then you would fill in with local identifiers for those they cannot. So there are various ways of doing this, and Jackie will be talking about a particular one next week. With that, we have now covered the material for this webinar. So let's do a quick summation of the basic points. First of all, URIs are the basis of all linked data, specifically URIs that represent entities, not web pages or records. Second, that unlike record-based authorities, which rely on text strings for disambiguation and are restricted for entry, URI-based entity management relies on URI and reconciliation. Third, ontologies such as BIBFRAME add semantic meaning to RDF by providing URIs that describe classes of resources and the relationships between them. And finally, when readying MARC records for conversion to BIBFRAME or any linked data, this I may not have stressed enough, the sooner the URI is in your MARC record, the better. Now you are ready, I hope, to move on to our next webinar next week in the series Embedded URI, which will be presented by Jackie Shea of George Washington University. I hope you found this webinar useful and encourage you to attend the rest of the series. So thank you for listening.
Great, thank you. If you all have any questions, please type them in the question box. We've got a few to start with. So to start, great presentation, Nancy. In addition to linking to BIBFRAME or ISNI, can we link to social media sites like an author's LinkedIn or the author's Twitter?
You know, I don't know exactly how those are put together, but if they have RDF in their background there somewhere, possibly you could. I'd have to do more research into that to find out.
Okay. The next question is URIs into MARC. In the LC webinar, one of the presenters strongly proposed not translating MARC, but starting from scratch to learn BIBFRAME. How do you view this suggestion / experience at Library of Congress?
I agree with them. I think we have two different things here. What I'm talking about as the beginning of is actually transforming our legacy data from MARC into BIBFRAME, which is something we will have to do if we go this route. On the other hand, if you are trying to learn BIBFRAME and to use BIBFRAME, it is really, really good idea to not do it through MARC, but to do it directly in either the cataloging standard you are working in, such as RDA, or directly in BIBFRAME itself. Otherwise, you end up just translating MARC into BIBFRAME all the time and don't really work within the new environment, but just are actually just using MARC by different words. That has been my experience, and I think it has been the experience at Library of Congress as well.
Thank you. Bear with me as soon as...
Actually, I will...
Sorry?
I will just say it is equivalent to when you move from AACR2 to RDA. At least here we found it much easier just to go cold turkey and move directly to RDA and forget about AACR2 rather than try to mix the two.
That makes sense. Thank you. So the next question. I work for a publisher and I'm wondering about possible roles for publishers under BIBFRAME. Since bibliographic data often originates with publishers, wouldn't it make sense for publishers to be URI targets for works we publish and their creators? These URIs could be included in the bib data we provide to OCLC, aggregators, ANI databases, etc. So that publishers is telling OCLC, Library of Congress, etc., that we mean that Leonard Cohen, etc., etc.
Yes, I couldn't say yes more strongly. As I said, the earlier you get those URIs into our data, the better it is. And it will it can help bring together the metadata of the publishing world with the metadata of the bibliographic world in a much stronger way than we've ever been able to do it so far. We would just love for you to do that. That being said, you have to pick your identifiers carefully. You either need to get it from, you know, some place that holds them for you, such as ISNI or the name authority file or something like that, or, you know, join ISNI or join NACO so that you can create those URIs when necessary. Otherwise, if you create local ones, you have to basically promise to keep them going and to support them. But yes, it would be wonderful if publishers did this.
Thank you. This is a comment. This is the best presentation so far. So thank you for that comment.
Well, thank you. Of course, I'm #1 of the series, so.
Have you used MARC Edit to add URIs?
Yes, and I think Jackie will be talking about that next week, because this is something, there's a PCC task force for URIs in MARC that Allison mentioned in my bio. And we did do some testing of adding URIs to MARC using MARC Edit, but I don't want to steal her thunder, so I think you will hear about that next week.
Thank you. Why are some of the ISNI/ORCID numbers linked to 9XX fields instead of the 02407 field?
If you mean in our local authority records, when we add them in there, the reason we do that is it's mostly just a machine thing. If we put them in the 9XX, if we get an update of the authority record, it usually just overlays our previous record, so we just don't want to lose those identifiers or have to have Backstage send them to us again. So we put them in the 9XX fields because our local fields are protected. That's the only reason. Also, when we started doing this, it was not sure whether we could actually put these in an 024 or like that. As I say, stress, these are only done locally.
The next question is, in MARC, how can we best show the URI of a work in relation to the work title in the 240?
The 240 is difficult. And, you know, I have looked at this and thought about it, but I can't give you an answer off the top of my head. I would have to look into it and get back to you on that one. Or I might make some silly mistake.
Can you talk more about the MARC converter tool that you mentioned? Can it be used by others?
The only MARC converter tool we have used so far is that was provided from the Library of Congress for BIBFRAME 1.0, and yes, anybody can use it. It does need to be downloaded and set up.
What is your opinion on system vendors and BIBFRAME? Where do they fit in the process, especially if we no longer need MARC-based systems?
Well, the first thing I'd say is I think it's going to be a very long time before we don't need some MARC-based systems. The one thing to remember about our ILS, our library systems, is we don't only do cataloging in them. We do acquisitions, we have payments, we have a lot of data in there. Data that often is the type that really is better probably in a relational database, such as your payments. Also, you know, the idea of linked open data is to make the data open. And yes, there will always be some data you have to hide, but you know, why would you really want to make your payments linked open data? I don't think you probably would. So there will be, for a long time, there at least will be that back end. Do cataloging as native linked data, there might be a back end that still has a bit of MARC stuck in it to hold all these things together. On the other hand, there are some various library systems are looking at linked data in one way or another and how they can provide services basically to help you create linked data. I mean, linked data, we require templates for entry, you know, we need places to hold the data, we need places, reconciliation services, and so forth and so on. There's a lot of things our ILS vendors can contribute to, and I think are probably looking into.
Thank you. Libraries don't always create authorities for all access points. To better prepare for conversion to BIBFRAME, would you recommend always creating authority records for all access points?
Well, access points are, of course, only some of the entities in your bibliographic record. There are also all those other controlled vocabularies, for the almost obvious, say, being the 336, 337, 338 fields, the content type, carrier type, and media type, which are RDA-controlled vocabularies and which are also expressible as linked data. Obviously, in an ideal world, yes, you would create authority records for all your access points. As we've seen, though, that's really not always possible. And of course, it always is when you convert data, the cleaner it is and the fuller it is, the easier it is to convert. I would not put out a recommendation that you must do this, because I don't think it's really possible, and I know personally I can't do it with my team, so I can't recommend that others would do it. One also has to be careful with things such as subject headings, which not all subject strings have authority records, and you're not allowed to make them in the first place.
Great, thank you. We have a few questions that we didn't get to, but we'll take those, and Nancy will answer them, and we'll send them out to everyone. I want to thank Nancy for her informative and interesting presentation today, and we're glad you could all be with us. You'll soon receive a short online evaluation form. Please take a few minutes to respond to the questions. Your comments are very valuable and will help the ALEX Continuing Education Committee plan future events. ALEX offers certificates of attendance and digital badges for participants, and information on these will be sent in the email you receive. I want to thank ALEX Tech Support Continuing Education Committee members Joseph Nicholson and Mary Aycock, as well as Megan Doherty and Julie Reese with the ALEX office. The support they provide make it possible for us to present these webinars smoothly. We hope you will attend the rest of the series from MARC to BIBFRAME, linked data on the ground, which are listed here. And ALEX has additional webinars, web courses, and e-forums throughout the year, and we hope you'll participate in other ALEX continuing education offerings. Thank you so much for joining us today.